Okay, well, let's get started. Thank you for coming to today's talk. My name is Sean Klingensmith. I work at InterSystems here in the support department. Today's talk is focused on developers, as you may have guessed from the title. We're going to talk about different tools you need and sort of get down to the nuts and bolts of how you can get started developing your application based on InterSystems IRIS inside of a container. This is an overview of what we're going to talk about. So first, it sounds like how's the volume? I sound loud to me. Okay. As long as I don't do that. So this is what we're going to talk about. First, we're going to start talking about how you can go about building a container image containing your application and InterSystems IRIS using this thing called a Docker file. Then we're going to talk about some of the details of how you can actually get your data into the container and your application and get it all built. And then we're going to talk briefly about how you can coordinate multiple containers if that's something your application is composed of. And then we'll do a quick demo showing pulling everything together. So let's jump right in. So, excuse me. So here's a quick example of a Docker file. Some of you may have seen this before. So you can think of a Docker file as a script that'll run to create an image. This will run inside a container to create the image with your application in it. Every Docker file will start with a from statement specifying the container image that you're starting with, and then you add things into it until you end up with your final application at the end, and you have a container. So in this example, we have the basic commands we'll be using. I mentioned the from command. Things like user, env, and workdir to set up the environment for subsequent commands, setting the effective user inside your container, environment variables, and the working directory. The copy command is how you actually copy files into the container from your host OS for use in the container. And then you can run your commands using the run command. This is just runs commands inside the container. So if we take a step back, all the script does, we start with a base image of InterSystems IRIS. We copy some files into the container, run tar to extract it, and then copy them where they need to be. In this case, they're web files that need to go in the CSP directory. Then we clean up after ourselves, and you see at the bottom the expose command. All that does is documents that there's something inside this container listening on port 52773 that something outside the container might be interested in. One other thing, the base InterSystems container image that we're using defines some environment variables like the ISE package installer, so it tells you where IRIS is installed in the image and the instance name, so you don't have to hard code these in your Docker file. So let's take real quick. Let's do a quick demo showing this. So if my computer behaves, you'll be able to see. Everyone can see this, hopefully. So if we look here, here is the Docker file we just looked at. Should be exactly the same. So if we just run this command, docker build, we're passing in here, called docker build, we're passing in the name of the Docker file that we're running, the -f switch, and then we give it a name, basic app, with the -t, the tag command, and we specify, importantly, the directory, the build directory that we're using. So here we go, and this runs really quickly because I already built this. Docker's smart enough to know to be able to use the cached results from the previous build. So now we have a Docker container with our basic application running here, or image on our system. We can run it with this command. And here we're using the -p flag to bind the 52773 port to our local instance, because as if you've seen any other of our other presentations about containers, you'll know that the container is running locally. It's in a it's in a restricted environment. We don't have access to it outside. Things running inside the container, we don't have access to them outside. So we have to specifically bind the ports that we are interested in when we call the docker run command. So at this point, our container is running. I should be able to go load up our application. Here, to make it easy on myself, I'll copy the URL. So here's the URL for the HTML file that we copied from our tarball. And hey, there we go. Here's our cool application. So maybe this is about as exciting as it looks. We just loaded an HTML file. What's so great about it? Well, it's in a container, but really what you want to do is you don't just want to copy HTML files around. You want to be able to know how to, really what we want to do is load code into IRIS, load our object code, load our application, not just some static files into the container. So if we want to load things into IRIS, we know how to get the file in using the copy command, and we know how there's some object commands you can run to load code. In this case, you can see $system.obj.load. Then you can execute it with the iris session command. So if you put it all together, you end up with this nice, beautiful looking command line. So this is how you can, inside your Docker file, you can call into iris to execute what you want. And in this case, we're loading some code into the user namespace, and we'll load and compile it. So if we put this together into an example Docker file, you do something like this, very similar to what we did before. Copy our files into our container. This time we start iris. We use our magic command from the previous slide to call into iris. Then we stop iris to clean up after ourselves. Does it look good? So we take this and we execute it, and it's not going to work. Actually, we're going to get an error here saying that iris isn't running. So what do you mean iris isn't running? You can see the previous command. I started it, right? If I look at my Docker build output, it says iris started up correctly. Why doesn't this work? In order to understand why this doesn't work, we need to take a step back and learn a little bit more about how containers work. So when we start a container using Docker run, you have to specify the container image that we're running. This specifies the initial state of the container when we run it, the files that are available to it, the libraries, the things that contain our application. Now, at any time, you could have more than one container running based on the same image. In Docker, when you do this, those files actually share, those containers actually share the same files. They're pointing to the same physical files. They don't have their own copy of them. This makes it really fast to start up a container, and it makes your system scale really well. It's really efficient if you're running hundreds of containers based on the same image, but you don't need to have hundreds of copies of the same files. Now, this is great and it's efficient, but it causes a problem if the container needs to modify any of the files that come from its base image. Things like a configuration file, maybe your IRIS CPF file, or some sort of configuration from the OS. The way Docker solves this problem is it uses something called a layered file system. So whenever a running container needs to modify a file from its base image, Docker will first copy that file into the containers, the running containers, to a writable section layered on top of the container's running image. This is called copy and write. So it copies the file into the writable layer, and then it makes the modification there. This way, the modification that a container makes to these files is only visible to that running container and not visible to the other containers based on the same image. This is how we implement the isolation that containers need inside Docker. Okay, so that makes sense. However, the base image that we're running for our cool application isn't really just one image. It's actually built up on a layer of images. So our application is based on a Docker image containing InterSystems IRIS. And InterSystems IRIS isn't a standalone image either. It's based on an Ubuntu image. So whenever we have a running container and it needs to access a file from inside the container, Docker needs to figure out where that file comes from. Is it in which image layer does it come from, or is it already in the running container's writable layer? And all this is handled transparently. Docker handles this for you. As far as the application running the container knows, it's just running in a normal file system with normal files. So what does it have to do with our application, our Docker file? Well, it turns out our application image here isn't just an image either. It's really built up on a bunch of layers. So let's take a look at this example. So here's an even simpler Docker file that, so like I said, every Docker file starts with a from statement that specifies the image that we're loading. When we run Docker build on this file, what Docker really does is it'll start up a container based on the base image that we specified. Once we have that container, then we'll execute the commands inside the Docker file, or the first command in this case. So in here, we're going to copy a file from the host operating system into the running container's writable layer. And then once this command is successfully executed, then we actually take that writable layer, mark it read-only, and then move on to the next line. The next line, we spin up a new container based on the base image plus the layers from the previous commands. Then we execute the command in this new container. When it successfully executes, we mark that layer read-only, move on to the next command, etc. So what we're really doing when you run the Docker file, or run the Docker build command, what we're really doing is building up a bunch of layers that comprise our image. And this is the final image that you take, you ship to your customers, or send to the cloud, or move on to the testing department, whatever it is you're doing. So your container image is really just a bunch of layers that we build up through this Docker build command. This is what we mean when we talk about the layer file system inside Docker. So with this information, you can see why the previous Docker file didn't run. It didn't work because each command is executed separately in its own temporary container. So we don't have the running state from the previous commands. So we can't start IRIS in one command and then access it in the next one. We need to actually bundle our commands together so that we can call into IRIS and then execute, or start IRIS, call into IRIS, and then stop IRIS all in the same run command. This way we end up with it does one command, and a side effect of this is that we end up with one layer in our image for this command instead of 3 layers like we would have previously. It turns out this is actually more efficient to have fewer layers inside your images, so this is actually a good idea to do generally. Just batch your commands together when you're writing a Docker file. Okay. Is anyone still with me? More or less make sense? Okay. There's one other thing I want to talk to you about Docker files before we move on. That's called this concept of a multi-stage build. So what we do here, we have a Docker file. It's very similar to what we did before. The main difference you'll see at the top is that we have this phrase from, we'll start with from InterSystems IRIS community, and there's this phrase as builder on the end. What that does is just gives a name to this stage of the build. Then we go through like normal, build up our work environment, copy our files in, execute some commands, and then we come to another from statement. At this point, what Docker does is we'll take, we take all the layers that we built up from the previous commands, we take them, we set them aside, and we start fresh with a new, fresh instance of InterSystems IRIS, a new container, and now we run a bunch of copy commands, except instead of copying from the host operating system, we're actually copying from the previous stage of the build. We're copying from the stuff we set aside. What this does is give us really fine control over what files are actually contained in our final image. This way, we can have a final image containing our built application. We don't need any intermediate files that could have been left around from the build process. This will allow us to have nice lean containers that don't have any of the junk that we don't need. It also allows us to carefully control the number of layers in the image. So you could have the same number of files with 10 layers, or have, the same files with 4 layers, or whatever. So having fewer layers will make your container run more efficiently later on. So this is a good idea to use when doing any sort of complex operations inside of a Docker file, is to use multi-stage build to sort of contain the allow you to make nice lean images. Okay, that's the most involved we're going to get. So if everyone's still with me, we can move on and talk a little bit more about how we can get some data into the container. So the first option is something we already talked about. Use a copy command inside your Docker file. Like we said, what this does is it'll copy a file from the host OS into your container at build time, so when you run Docker build. If you modify the file after that and you want the changes to be reflected inside a container, you need to build your container again. You have to run Docker build again and then restart your running containers. That's all you really need to know about the copy command. Other than that, the only other thing you need to know is that the files need to be in the build directory. So that's the path that we specified past the Docker build command. You can't access other directories using // or anything like that. It has to physically be located in there. So, so that's build time. But what about runtime? How can I access files from a running container without having to rebuild it? There's this thing called bind mounts. So a bind mount will allow you to access files from your host operating system in real time from within a running container. So this is an option that you specify in the docker run command. And it's pretty straightforward. You just specify a directory in your host operating system and a directory inside the container, and then you can access the files directly within the container from that path. This is really useful in a development environment if you put your source files into a bind mount. So then you can make modifications in your favorite IDE on your local system, on my own laptop, and see those changes immediately inside the container. I can also build things or whatever I need to do from the host. The key here is that you can share those changes from the host OS into the container in real time. Another option is called volumes, or named volumes. Like bind mounts, this allows you to access files from your host operating system. But unlike bind mounts, you can't modify the data from your host operating system, or you generally shouldn't. The data will be stored in a directory that's managed by Docker, so you can't modify it directly. It has to be modified inside the container. But this is great for persisting data. So if you are in a development environment, you keep spinning up new containers, running some code, and then throwing away the container, anything you want to keep, you'll want to put in a volume or in a bind mount. Volumes are great for this. So think things like data. So you have your databases that contain your testing data, or it's a key one, or also configuration information that you might want to keep from one run to the next. This is a good place to stick them inside a volume. So a named volume to create beforehand. You use this docker volume create command, and then you can mount them in much the same way as we did the bind mounts using that command. We'll see an example of how to do this in just a minute. Before we move on, I also want to have a brief discussion about how you can configure your IRIS instance. Now, obviously, so I'm talking about things like setting up your namespaces, setting up your databases, your security settings, anything you need to set up IRIS anything you need to do to make your application run inside IRIS. Now, you can obviously run an object script routine to do all this for you. However, if you have a complex situation, that's going to be a lot of work to write code to do that manually. So we have this thing called an installer manifest. Again, this is useful. This has been around for a long time. All this is just a way to express your system's configuration in an XML file. So this is great. If you can specify all of your system configuration in an object script routine and an installer manifest, then you'll be able to automate the install of your IRIS instance, and you can store all that in source control. You can pull it down into your Docker file and just set everything up really fast. However, this could be a lot of work to do if you have a complex situation. If you don't want to do, there are many reasons you might not want to do that. If you can't do that, there's this feature called durable sys. If you were in Joe's talk just a few minutes ago, Joe Carroll, he talked about this. Really, all this is a way to specify that IRIS's configuration lives in some directory outside of the IRIS install directory. The advantage here is that you can map that to a volume or a bind mount, something that lives outside the container. That way, you can start up a container with a vanilla instance of IRIS, do whatever configuration you want, go into the management portal, run some scripts, do whatever you need to do to make it, configure it the way you want it to be. And then since that configuration is stored outside the container, you can throw away the container and spin up a new one, and it has the same configuration. That configuration stays around. So this is a useful tool for setting up IRIS, even if you can't store everything inside source control. If you put your configuration inside a named volume, there's also great ways to back this up and move it to another system if you need to migrate your development configuration to somewhere else. Okay, so as a brief overview of configuration, there's one more thing I want to talk about before we get to our demo, and that's how you can coordinate multiple containers. So multiple containers. So this would be, so if your application consists of multiple instances of IRIS, you're going to need to know how to do this. So if you're using mirroring or ECP or a shard cluster, you're going to need to know IRIS is you're going to want to have IRIS running in each instance of IRIS running its own container, and they'll need to know how to talk to each other and where the other instances live, etc. Also, if you're running the web gateway, so if you have an Apache instance or Nginx with the web gateway installed, you'll probably want to have this running in a separate container. You'll need to know where IRIS lives. Similarly, if you have an Angular app or a Java application, again, these should all be in their own container. So you're going to want to figure out how to start these up and have them know where IRIS lives and to do all that efficiently. So in order to solve that problem, Docker has this tool called Docker Compose, which uses a configuration file with the same name. And in this case, what you do is you'll specify the different containers, different types of containers that your application uses, or services in the Docker Compose language. Here in this example, you can see I have two services defined, one for IRIS and one for the web gateway. I specify the Docker file that I can use to build these containers. It's important to note in Docker Compose, you can specify the Docker file that you specify your services as a Docker file, or you can specify the name of a container image that's already been built. This is useful. You tend to do this if you're in a test environment. You just want to grab the name of an image that you already have. You don't need to build it from scratch. But in development, I find it useful to use the Docker file, because this will let me use Docker Compose to build all my containers and start them up from one command, instead of having to run a bunch of Docker build commands and then run Docker Compose. But however you do this, it's up to you. But then the really useful part of this is you'll see we're specifying the runtime parameters that we want for these containers. So we specify the ports that we want to bind to the local instance. And in this case, we're specifying in the volume section. If I walk over here, I can point with my laser, maybe. It's not working, whatever. You can see in the volume section over here, we're specifying, in this case, we're specifying a bind mount. We're mounting our source code into the container using a bind mount so that we can access this in real time. So the key thing here is these are all parameters that are passed to Docker run. If we specify them in a Docker Compose file here, it makes it a lot easier to start things up. We don't have to type in 10,000 parameters every time we start our container. So with that information, I'm going to talk about our demo. So you can get the code for this demo from GitHub. All you need to know is how to spell my name. Or actually, my slides are in the event app, so you'll be able to pull these up later to look at it. Okay. So there's our previous run. Stop that. So over here we have so here is the Docker file that we're using. So this is what I showed previously for the multi-stage build. You can see we have the build phase. And this screen is smaller than I thought it would be. So the key things to note, we're doing a multi-stage build here. And inside here, instead of what we're doing is we load my setup class. Actually, you can read it a little better. And then we're calling setup. So this is our installer manifest we're using to configure IRIS. And that will end up loading the code from the install directory. Then if we go back here, we can do Docker Compose. And if you specify the -- build command, since we put the Docker file in the Docker Compose configuration file, we can pass the -- build command to rebuild our image. And I'll pass -d to run it in the background. And so it runs real quickly, and we'll see Docker image ls. We can see not image, container ls. That's why I don't type things in a live demo. You can see we have two containers running. We have our web gateway container and our IRIS container. And we can access the web gateway on port 8080. It's mapped to the Apache's port 80 inside the container. So if we come over here, we can go to 8080 and was demo index.html. So here's our great demo application. It's a nice messaging app we set up. So this has already been pre-populated with some dynamically generated data that was done from our installer manifest. So in here you can just type our thoughts about how containers are fun to work with. And maybe it loads, yay. So that's a cool sort of little app. But so what we have here, so since our source code lives, so since we have a bind mount set up, like I said, we specified a bind mount to map the source code from our host operating system into the container. So if we go to over here, we have the HTML file for our page. If I just specify, so if we can make a change here like this. So what I do here, I'm modifying the file on my local laptop. Then if I go into the container and refresh the page, that change is reflected immediately. So here I have a change I made on my local system, but then I make a request to my web gateway container, then talks to the IRIS container and loads the file from the bind mount. So when you start working with containers, I find that one of the most frustrating things is how to get things in and out of the container. So I think setting up bind mounts and volumes, if you set them up correctly, it can make your development a lot easier. So, and then that's just modifying static files. So if you want to connect to the code inside IRIS, you can use Atelier just like you would for a normal system. So we set up the port forwarding for the local instance. You can set up our Atelier. So again, you just point it to localhost and then the port that we specified in our Docker file, which in this case was 52774, or the Docker compose file, excuse me. You can see, specifying 52774 goes to 52773. So we can connect to our IRIS running in the container. And go back to, I think that was the namespace tab. Go to the project tab. Go find, here is our code. This is the code we're using for our REST API. This is our manifest where you see the XML where we set up our configuration and loaded our random data. Sorry. But if we make a change to the code here, we can specify, say, if we want to add a title to the name, the username, we could say something like Mr. Sean. If we save. So in this case, because I spun up a new container, Atelier didn't know how the connection was supposed to work, so I'm telling it save the copy that I have locally to the server. So now I'm loading the code into IRIS, I compile it, now I can go make my tests, and again, I immediately see the results. And if I come back here, I can stop the container. Eventually, you can rebuild the container and have all the changes that we still made because the source files are loaded outside the container as well. This time the build should take a little bit longer because we actually have to do work. Yeah, and there we see calling to IRIS, executing all our setup. It takes a second. There we go. Goes up again, and then we should see no changes because we just built a new. What we did here, we just built a new container based on the source code that we already changed. And you'll see we have different data here because we regenerated all the test data. So The goal here is to show how you can go about setting up a container, installing your application, and then start working your development and start iterating. You can throw away the container, build it up again, and still have the state that you're interested in. Maybe not your test data, but at least your code and all the changes that you have. So that was the demo. So we move back here. So that's what I have. I think we have a couple minutes for questions. And again, here's a slide. Let's go back to the PowerPoint, actually. Maybe. Okay, so again, here's the schedule for all the other container talks we have this week. I have a couple minutes to talk about questions, and then if you still have questions, you can come to the other presentations and keep learning. Does anyone have a question? We have 2 microphones. Okay.
Can you just show the Docker file that showed how you were, you had some do commands in there. I was just curious, maybe you're going so fast, how those were actually getting executed inside the container.
Okay, the question is about how we're executing commands inside the container, inside IRIS, right?
Yeah. It said do this or do that, you know.
Yeah, so this is the Docker file that we're executing. So it's do $system.obj.load.
So where's do coming from? What's do?
Do is an object script command.
Oh,
Sorry.
What's running it? What's running the object script?
Yeah, so here we're doing iris session. Right, sorry. I started one. Yeah, I went through this quickly. So what we're doing is we're piping the commands into iris session, and then we're concatenating all the commands using ampersand character.
Right.
Sorry, I meant to go into that, but I think I slid past that.
Gotcha.
That make sense?
Yep.
Okay.
So that's how you basically do it. That's how you basically do. You're executing anything inside of a Docker file
Right.
to get it to load or to run a task or anything like
Yep.
that. You kind of pipe it into this
Yep.
IRIS session. And so that's just a running listener for commands or something?
So iris session is just a command line that you can use, to call into iris to do anything, to log in. So if you just do iris session instance name, then you're going to have an interactive terminal to use.
And you're saying user. Okay.
Yeah, and I'm
All right,
passing
all right.
the
Yeah, that makes sense. Okay.
This is the name of the namespace, so user is the default user namespace installed. Yep.
Is there a practical limit to the string length of those?
The question is about the limit to the string length of the command that you'll pass into iris session.
Right, so you've got the run and a bunch of characters. Is there a limit, a practical limit?
Not aware of one. Yes, you can also redirect a file. I think we have a comment about that.
Hi, I'm Connor. I'll be presenting this room in an hour or two, but just to answer that, so there's some weird interplays between the way that ObjectScript deals with whitespace and certain types of special characters, which means that often what you want to do when you get past 1 or 2 lines of this is you want to pack all of that into a file, and you want to have your ObjectScript in your Docker file be as minimal as possible. And a bunch of best practice here can currently be found at github.com/intersystems/container-tools. What we have published there is the Docker file and the shell scripts that we actually use to build our own images in-house. So go forth, check it out, and I hope it works for you.
Okay, thank you. Can you?
So I've been running InterSystems in a Docker for years now. Just it was the old hack. Somebody, I can't remember who actually created the thing in the first place, but it was all curiosity to me, and I can't. You went quick enough for me not to really figure out where it is. Where it would be the data in this? Is it a
So
if it's just a large database and it's continually changing, and what's the recommended way? I guess you just went over all the different ones, a volume or a bind mount or all that.
Yeah. So in this example, I just have all the data stored inside the container.
Which you would never do.
Since it's not very big. Yeah, in real life, you don't really want to do that. You would want to have that mapped out into a volume or a bind mount.
Okay.
Yeah. Yep. So you have. I'm sorry, what was the question?
Just a use case for patient care, like how I can use IRIS in patient care.
How would you use IRIS? Or IRIS in containers?
So
Or
I have like HL7s coming in
Yeah.
into the system. So I have HL7s coming in. So what can benefit me? Like IRIS, I can use in testing, or I can use in developing, like a use case.
Right, yeah, so the use case for using containers, I mean, is really just to try to keep the consistency and prevent the system drift as you move from stage to stage. So how that applies to a specific industry is sort of a bigger question we sort of talk about offline. I just want to save some time. We have a guest speaker coming in just a minute, so we can talk about that offline. So thank you. So like I just said, we have, excuse me, sorry, it's John Murray? Yeah. John Murray from George James is going to give a presentation on their code editor plugin. So,
let's see if the technology holds up for me too.
And yeah, if you have any more questions about Docker or about Iris for that, feel free to stop me in the hall. I'll be spending a lot of time in the Tech Exchange. You can find any of the other InterSystems people who can find the right resources for you to talk about that.
So yeah, thank you, Sean. My name's John Murray. I work for George James Software, and the opportunity here is for me to share a few minutes of my experience over the last couple of weeks. I set myself the challenge of building a container that can demonstrate one of our software products called Syrengy, which is an extension for Visual Studio Code that would allows you to edit code using VS Code. And we've had this out for about a year, but one of the pain points really is getting people to set it up, getting them to install what they need to install in the environment and making it all work. So I've used the community edition of InterSystems IRIS container, and use that to build a container which is hosted on an online service called GitPod, and at the URL that's on the screen there at the moment, you can go there, follow through that page. You need to have a GitHub account in order to use GitPod, but from there you can launch up a container running in the cloud. It's private to you, and it's built with these techniques, so that effectively there's a Docker file that's done the build. It's loaded into that environment. Our software, it's installed an instance of InterSystems IRIS Community Edition. It's installed an instance of Visual Studio Code, and bundled that all together. And the outcome of that is that in my web browser here, I have, let's see where my mouse has gone to. I've got two tabs. This is just in an instance of Chrome. In one of the tabs, I've got the interface into the GitPod framework, but that's really kind of the launch and control environment. The second tab I've launched is effectively an X desktop onto the Ubuntu machine that's behind in the container, and from there I can go onto its context menu, launch up Visual Studio Code, which is running out there on the cloud somewhere. My screen isn't big enough to make it all visible here, so I have to do a bit of resizing. And so none of this is executing on my machine. The only thing that's executing on my machine is the Chrome browser that is providing the connectivity here. And let's try and get it all roughly visible here. So in there, I've got inside the Docker container that I built, I can say open up a workspace from home. I have a workspace called user .code workspace. And this is using our Syringe extension with the VS Code. In that namespace, I've loaded in a class called demo1.cls. And that class implements a couple of class methods for calculating prime numbers, finding prime numbers. One of Syringe's features is the ability to debug. So I can go in here, say I'd like to debug the primes class method with an argument of 1. Start the debugging. And over here, so give us a bit more space. We can start stepping our way through the code here. And the relevance for it in the context of this talk is that this is all executing somewhere out there on a completely self-contained instance, which required no installation in order for me to demonstrate it on this machine. It won't work on your mobile phone because the screen just isn't big enough, but anything else, you should be able to do it. Thank you.